Hi all. So this evening I thought I would build my battery, which is, for a bit of an old schooler like me, quite an amazing thing, and it's quite exciting. But here it is. It's from Fogstar and it's a 280 amp hour lithium iron phosphate, and this is their DIY kit. You save £300 from the off-the-shelf battery. I'm going to do a build video of this battery. There is another one on the internet which was very useful to me, so I thought I'd just contribute to that and add it to my playlist. And it's actually really simple. In this box, which I have not taken apart yet, but inside here is the circuitry for balancing of the cells and the BMS, which I do need to download the app to program the BMS. The BMS, if you don't know, BMS stands for Battery Management System, and it's basically a solid state switch that is connected on the positive outgoing of the battery, and it's quite common with lithium batteries. Basically, what does it do? It does many things. It controls temperature, so it looks at the temperature, whether it's high or low, and it will limit or stop the output current or input current if you try to use or discharge the battery. It also looks at the individual voltage of the cells, and so via the balance board, when you charge in your battery, it will balance the cells. And that is the fundamental thing that means that a lithium battery will last for years and years. This battery potentially should outlast me. I know that's maybe not a long time, and why is that mainly? It's because of balancing the cells. So as long as you look after a battery with regards to temperature and charging and discharge currents, things like that, there's no reason why it shouldn't last a long time. One of the things that you may find is, certainly with an iPhone, I don't know if you've ever noticed, but when it gets to 80%, the charge rate dramatically slows down. And that's what will happen with this. So that you can charge your iPhone up really quick to 80%. The charge controller for your iPhone is in the phone. It's not in that thing that you plug in. That's just a power supply. The same goes for this. Whatever charge I put into this battery from both my van running or my solar panels or from electric hookup charging, the battery will only be given a certain amount of current under different conditions, and when it's nearly full it will charge slower and slower and slower, and that's because the cells are being balanced. Anyway, enough of that, let's get into this. So forgive my head or my back, but let's take the lid off. This does seem really high quality, by the way. These are little Torx screws. It's a metal box, obviously, with it being lithium. Versions of lithium batteries, by the way. Okie dokie. We need a Phillips. So what we've got here is the balance board, and on here are some small gauge wires that go to each cell, and it is those wires that will be charging the cells. But it can be, you know, that current can be as little as 500 milliamps, because that's all it needs to be to balance the cells. You can't stick 80 amps in a LifePO battery until it is 100% charged. You just can't do it. So that's the balance board. All that is a circuit board, and all that is doing is literally connecting up each of the cells. Somewhere in here there is going to be a kit of bolts, because there are only the minimum amount of screws in this box. But there's quite a big box there that'll have loads of stuff in it. This is the end cover that I'm taking off just now with the terminals in. This is where the terminals will be. And also on here, there's a place for a switch. There's literally a touch switch, and you can, it seems crazy, you can literally turn this battery on and off by literally touching this switch. All our cables, the BMS. So there's the BMS. There is the on and off switch for the battery. And those are the jumper cables for the balance board. And that is 2 temperature sensors, which gets buried in the battery. And then in here, there's a load more bits. So some I think that is a jumper buzz bar, flexible. There's a 400 amp fuse, terminal, mains cable. I think that one's the neutral. Screws for the compression box and various bags of screws. So there's all my bits and pieces, and from these bits and pieces we will put together a very clever battery. So we completely line the box with whatever this is. I think this is like an insulating material. It feels like mica. Okay, so lift the cells in, and we stick this closed cell, yeah, like that. I put these cells in basically opposite way round to each other. So reverse the positive and negatives. So we start with negative in that corner. So this cell here, this is 280 amp hours at 3.2 volts. Hugely powerful. Last one, that way around. So then we've got negative there, positive there. I will stick on that cell, and then the other piece of this is fiberglass apparently. The other piece of fiberglass will go on there. Okay, and then there's 6 screws like that will squash it all together. This is called the compression plate, and there's a load of screws which go in there. The electrical part of it is pretty straightforward. You're basically dealing with positive and negative. If you can build your own battery board, if you can build your own distribution system for your van, there's no reason why you couldn't do this. I think that Fogstar just produced a brilliant kit. Closing up this compression plate. So next we've got this, this is more sticky back closed cell. This goes over the top of the cells like that, and I would say that that is basically supporting the balance board. So now we've got our connectors for the cells. Okay, so that's basically connecting the cells together in series. 10mm socket on there. I'm just going to nip them up for now because I have got to attach the balance board terminals onto those. Put the terminals on, and we've got 8 of these black screws. These are the main terminals from the battery. Again, the quality of all this is brilliant. These screws are exactly the right length. Got a nice little gasket under here. That is where the fuse is going to go. That's a 400 amp fuse, and that is going to protect. That's like maximum charging, maximum discharge. Now on here is fuse cable. So that's the positive outgoing terminal. This is the negative outgoing terminal. Negative terminal. There we go. What I'm installing now is the switch, which will actually turn the battery on and off, which is pretty cool. So whilst I have got on my board, I've installed isolators, etc. Literally on here there's a button. You can just turn your battery on and off. Okay, then we're going to take the balance board. We want 4 screws for it, which I think are these, which are going to screw into there. So just putting the mounting screws in the balance board. Did notice on these batteries, just to probably try and confuse you, it's the Chinese, you know. The terminal with the black ring on is the positive. So we have B negative. This terminal goes on cell 1. These balance wires, it doesn't matter whether you put them on which side of this buzz bar link you put them. Positive cable that goes to the BMS, and then is our BMS. So we've got, strangely enough, this is in the negative part of the battery, so we put that in there, and then that is going to be mounted with some small screws. BMS mounted. And I'm figuring what we do now, bolt the negative to the negative terminal. So then we can tighten all those down. I think solid state switches have come a long way, haven't they? This BMS has got to be rated at nearly 400 amps. See how many times I can say BMS in this video. Now is connect the balance board to the BMS, and then we've got the positive sensor wire, and we will connect positive cable. And then these are the negative terminals. And we've got the wire going to come up there. I think this is all in flipping Chinese. The switch wire into that terminal there. So now we can tuck these down neatly and out of the way. Make sure we're not squashing anything. Everything just fits. All these screws line up perfectly. I'm not having to try, you know, force any screws in. They're all just going straight in. Exactly. There's all our end cap screws in. What we've got now is the temperature sensors. So we plug them into there, and then we're going to stick one down there and one down there. Just took those wires out of the way. So on this BMS, there are 2 temperature sensors. Obviously, the system needs to know the temperature of the cells. And so you tuck them down the sides of the cell. So you literally just push them down. So that's in between cell 4 and 3. And the other one here is between cell 1 and 2. That is pretty much it. What I'm going to do now, switch it on. See the red light? Battery is on. I need to program the BMS, but the next step is to put a lid on. And we've got a load of these screws. So I've successfully connected to the BMS with Bluetooth. It's giving me all the battery information. There's various settings on here, some of which I've gone through, but it's basically a matter of figuring out the app. So there we go. That's built my Fogstar 280 amp hour battery, which I can turn on and off with a switch. It's got a handle on each side to lift it. It probably weighs about, I don't know, 30 kilograms, but very impressed, really impressed with it. I'm looking forward to getting that installed. So I've had the battery built for a couple of weeks now. The app is okay. It's quite basic. I think that if you get a Fogstar battery off the shelf, there is a Fogstar app which uses in the background the app which I have on my phone, which is just the app for the JK BMS. It's quite basic, but it tells you a whole host of information on the first page rather than any fancy graphics or anything like that. So I did a little test actually. I powered the fridge up and I left the fridge running and started it on the Friday night until Tuesday night. And according to the app, which I don't know if it has to be calibrated, you know, to see like it go fully flat and fully charged. I've seen that mentioned a few times on various YouTube videos. But anyway, it took 9% out the battery, but that was with nothing going into the battery. So I consider that, you know, if I had my solar on, I sort of worked out that I only need about 4 or 5 hours to put that energy back. So pretty much really this battery will run this fridge, and including the solar, it will be pretty much without any detriment, if you like, during the day. So yeah, so really pleased with that. I think it takes about 20 watt going by the app. Also, my girlfriend keeps hankering on about a hairdryer. I got this one off Amazon. I thought it was 900 watts, but it's actually 1,000. So this is it. You get it in a really nice little pouch. It's a travel hairdryer. Pops up like that. When I first saw it, I thought, small. It is 120 volts or 240 volt. You do get a travel adapter with it as well for the mains plug. However, and I also didn't know if the inverter would run it. So I've got a 1,000 watt Renogy inverter, and this inverter has a peak of 2,000 watts. I've had experience of a few other inverters in the past, cheap ones, and I have found that, you know, sometimes they can be noisy, and also they just do not like surges. Even switching a TV on. As much as my girlfriend was really into this hairdryer and thought, this is amazing, I said, don't hold your breath, we've got to try it yet. So I connected up the inverter to the battery, switched it on, plug this in, switched it on. It works absolutely flawlessly. The inverter fans don't even start running, and you know, this is drawing a full 1,000 watts. There will be a little bit of a surge when you first start it on, but it's a fairly, I don't know, it's a fairly small motor, so probably not a massive surge. It puts a decent load on the battery, puts 90 amps on the battery. Yeah, pretty much sorted really. That is the only thing that I was going to need an inverter for really. I may try like a slow cooker or something in the van. So from here, really that's going to be installed in the van. 2 short beeps, 1 long beep. That battery's now turned on. And then we can turn the inverter on. And while it's sat there, it's completely silent. Nothing. And as I say, even after running the hairdryer on it for 5 or 10 minutes, it still just sits there, does nothing. It's absolutely brilliant. Really pleased I got it. And then to turn the battery off, you just hold the switch down for 5 seconds and that's off. And the inverter just beeps because of the low voltage. So that's it. That's all tested, all good. All that remains now is just to fit it in the van. Hi all. Well, battery's installed in the van. Learning stuff about stuff all the time. This is certainly one of those things. A little bit of worry yesterday. I thought I'd got somewhere like a massive drain on the van. When I built this battery and connected the BMS to it, it was telling me there was, I think, around 55% in the battery. I installed the battery. I've installed a tracker. You were required to take the tracker out for a 5-mile drive to initiate it, so I did that. And I could see on the app for the BMS that the Renogy was working fine. It was taking power from the starter battery via the alternator, obviously. So it was putting about 42 amps into the leisure battery. I could also see on the Renogy how much the starter battery was being charged as well. So all good. When I got back that day, I had to change some settings on here because the maximum charge current that was set was 25 amps. And so what was happening, it kept tripping out basically. It kept stopping the charge because it was over, and then it would wait for like 60 seconds and then carry on charging. If that charge was then over 25 amps, it would knock it off again. So there was some charge going in, but I noticed that it kept turning off. So a little bit of a learning curve there. Anyway, I left the battery on, started some shifts at work, and on I think it was the 3rd morning, I got a notification on my phone that the tracker was offline, that power was off. So I thought, that's strange. So I got home, checked everything out. All the power was off in the van, connected the app, and basically the battery was flat. It was disconnected. The BMS had disconnected it on low voltage. And I thought, that is really strange, because if that was at 69% was what it was showing on here after I turned the van off, 69% of a 280 amp hour battery is a lot of power. And I'm thinking, where's all that power gone? So a little bit of investigation ensued. I checked that the power wasn't going back to the starter battery through the Renogy. So I verified all that. I'd measured the drain in the van and it was at like 300 milliamps. So I'm thinking 300 milliamps on a 280 amp battery would last weeks. So I was a little bit unsure what was going on, and it was a little bit of a stressful time because you're thinking, I've spent all this money, done all this work, what is happening to all this power? It suddenly dawned on me, hang on, what if the BMS doesn't know what the state of charge was of the battery? And it's looking like that was the case. I've got a Noco Genius 10. These are really good battery chargers. I stuck the charger on yesterday and you could see straight away the battery was charging. It's charging at just over 9.3 amps. So I worked it out that was going to take around about 30 hours to charge that battery up. But during yesterday, when I had it on charge, the BMS was like ramping up the amount of amp hours that's gone in the battery. And I thought, this just can't happen. This battery charger, I mean, by the end of yesterday, I think it was from 0 to about 240 amp hours. That's just not possible one day. 24 hours, yeah, at 10 amps, but not at like 8-9 hours. So I've done a little bit of research, and there's still quite a lot to learn about the BMS. One little thing that I have just done, I don't know if you can see on there, it shows a calibrating voltage. I've got a really good fluke meter, and basically what you do is you measure at any point the battery voltage, and you tell the BMS what it is. That's the calibrating voltage. And so from that, it works out what the cell voltages are. So currently it's at 13.6 volts. It's been showing the battery capacity at 280 amp hour and 100% ever since I checked it at 7 o'clock this morning, and it's currently 11 o'clock. It's still putting in 9.3 amps. But on there you can see, hopefully, the cell voltages, and it is the cell voltages that will determine when the battery is fully charged, and the BMS will turn off the charge when it gets there. So on the settings page, if we go to advanced settings, so I don't know if you can see it, but there's a multitude of settings on there, and state of charge 100% is 3.56. So basically when the cells get to that voltage, the BMS will start to cut off the charge. And I found a little chart online, and it shows the cell voltage at various states of charge, and currently mine is at 3.4, which is around about 95% charged at the moment, but it's heading up to 100%. So whilst I was using my battery, so I ran the fridge for 4 days. I then had it in the van. I've been testing lights and that, testing the fridge in here. Not using an awful lot of power, but basically the battery was virtually flat in the first place, even though the BMS was saying it was at the most 69%. It was a long way off that. So there we go. Yeah, it's a lot to learn. It's new technology, isn't it? You know, once you have built your battery, you've then got to learn how to set up the BMS. I've read online that you should charge and discharge the battery for up to 4 or 5 cycles. That's going to take quite some doing, and it will only be at that point that your BMS learns the capacity of your battery, if you like. So yeah, I just wanted to add this bit on the end of this video just to help anyone out that's got a battery. I don't know if you buy one off the shelf whether it would already be cycled and whether the app would already be set up. I don't know. I guess this is one part of the DIY process that you need to learn. So there you go. It is all basically down to cell voltage, and they're all on there. You can see they're all in different colours there. The red is lagging and the blue is leading and the green is average. There is a setting in there to trigger the balance charging. So you set what the voltage is. So at the minute, mine is set to 0.01 volts. So if it deviates more than 0.01 volt, the balance charger will kick in and it will bring the cells that are lagging. At the minute, the biggest difference between these cells is 0.004. So we're quite a long way off the balance triggering just yet. So there you go. Just thought I'd add that. I hope that helps. I'm still charging mine, and we'll see how we go.